So I will present some data that we have on protein foods. Um, that is, some of them is available in the West African food composition table, some of them in the South African food composition table, and some of them is not published yet. So for the nitrogen, we use the Dumas method for meat and the Kaldal method for the dairy products. For the amino acids, there was 3 methods. For the 17 amino acids, the sample was hydrolyzed with hydrochloric acid. Then we used the FMOC reagent for derivatization, HPLC, and fluorescent detection. We use a gradient of pH, methanol, and acetonitrile as eluent, and we use an internal standard. Then for cysteine, we use the same method as this, but prior to the steps, we first oxidize the cysteic acid with performic peroxide solution. And then we go through the same hydrolysis and the same method here. And for tryptophan, we use enzymes to hydrolyze, and then also HPLC. And the quantification was done with a concentration range of the tryptophan standard. And then I recalculate all the amino acid data to use this preferred method of individual amino acids, where you calculate that less the molecular weight of the water. Then, okay, so this was part of Hetty's PhD study. So Hetty has done on beef. I will present the data for the age group B, fat code 2, but she has 3 age groups and 6 fat codes in her data, and you can see there's a lot of cuts. And when you use the protein and for the carcass, you get a mean value of 19.37. If you look at all fat codes, age group B, and if you look at all age groups, but fat code 2, you get 20.13. For these samples, I also calculate the sum of amino acid residues, and I get 18.13 and 16.53 for fat code 2. So just to summarize this, the protein can range from, just by looking at the values, from 16.37 to 22.07, and the amino acid residue range is from 16.53 to 18.13. If you recalculate the conversion factors, you get an average of 5.74 over the whole carcass. Then another study by Nicolette Hall, we get, she has 4 age groups, but only 3 cuts, and we get a mean protein of 19.1 and the amino acids, and we get the range from 16.75 to 18.07. And if we recalculate the conversion factor, we get 5.31. Then I have for 2 studies for lamb and mutton. In this study by Ina and Janine, we unfortunately do not have amino acid data, and this was done on whole cuts. Then from this study, we used the same cuts, but it was retail cuts, so it's like you would buy it in the shop. And the amino acid values for this, and again, when we recalculate the conversion factor, we get 5.25. I also have values for chicken, for fish, and for pork. Again, all the same steps, and we get an average conversion factor for chicken of 5.16, for fish, if you can average those two, 5.24, and for pork you get 5.08. Then for dairy, we get, we have a lot of dairy data. I just choose a few, and we get a conversion factor of 5.68, except for the sweetened condensed milk that has a very high amino acid residue, total amino acid residues, higher even as the protein content, where we use a factor of 6.38. Then this is for high protein supplements, and I just include this so that we can take note. For the whey protein supplement, we use a factor of 6.38, and for the rest, we use a factor of 6.25. And you will see that especially this one, if we recalculate the conversion factor, we get 4.69. And what happened with protein supplements is that they add individual amino acids like very high glycine. And although they sell it as a supplement that is supposed to be meat-based, there's a very high concentration of glycine in this one. So just my concluding remarks. On average, the protein content using the Jones factor overestimate protein content versus the sum of total amino acid residues. But in each case, if you look at the ranges of the protein and the range of the amino acid residues, it is within this protein range using the Jones factor. We must also take method uncertainty into account when we decide on other conversion factors. For nitrogen determination, it's an easy method. For amino acid residues, it will have a much higher method uncertainty due to the many steps included and in the analytical process. Also, we must remember that for meat, you get nitrogen from various other substances that is not necessary amino acids. Also, we did not determine asparagine and glutamine, which is both amide amino acids, and also there can be an incomplete recovery of the amino acids and amino acid losses during hydrolysis, which also can contribute to a lower value for the amino acids. Thank you.